Hi, this is tutorial 4, Life Con. We're going to go through the solutions to these questions, and as you go through the video, make sure that you have your tables and your calculator at hand so that you can pause the video and check the calculations and so on. Question number 1. The future lifetimes of two people, one age 40 and one age 50, are independent. The survival function for 40 is based on a constant force of mortality, mu equals 0.05. The survival function for 50 follows de Moivre's law with omega as 110. You're asked to calculate the probability that 50 dies within 10 years and dies before 40. So what are we trying to find? We're trying to find that 50 dies within 10 years and dies before 40. So I have a 1 on top and colon 40. That's what we are trying to find. Okay? So which means that this guy 50 has to die first. So that's what you write here, okay? Again, right? 50 has to die first. So we have TP50 mu 50 plus T. That's the idea. That's what I call in my lecture killing 50. Okay, so TP50 mu 50 plus T. And when 50 dies, note 40 is alive, so TP40. And we are talking about within the next 10 years. So we integrate from 0 to 10 with respect to t. That's setting up our integral. Remember 40, his survival function or her survival function is based on a constant force of mortality. So TP40 is e to the power of negative 0.05 t. That's from the formula TPx equals to e to the power of minus mu t. And we know that 50 follows de Moivre's law. So TP50 mu 50 plus t, again, TP50 mu 50 plus t will be equals to 1 over, remember it's omega minus x. So it's 1 over 110 minus 50. Again, it is 1 over omega minus x. Let me say it again, yeah? It's 1 over omega minus x from our LifeCon 1 days. So it's 1 over 110 minus 50, you get 1 over 60. So plug that in. Where you see this, excuse me, where you see this, you plug in 1 over 60, and then we have e to the power of minus 0.05 t. And this is a simple integral. Take out the 1 over 60. This is an exponential integral. We are going to use the integral e to the power of ax dx. We have 1 over a e to the power of ax plus c. Plug that in, use a calculator, and you'll get your answer. Question number 2. You're given X is subject to a uniform distribution of deaths over each year of age. Y is subject to a constant force of mortality, 0.3. We are given QXY with a 1 on top of the X equals to 0.045. You're told that Tx and Ty are independent. We're asked to work out Qx. And we're looking at this contingent probability. I repeat, we're looking at this contingent probability with X dying before Y in the next year. So that's QX1Y, which means first we need to kill X. That will be TPx mu x plus t. And when X dies, Y is alive, so I have TPY. That's what you see here. And because we're dealing within the next year, okay, we're dealing within the next year, so your integral goes from 0 to 1, and we are integrating with respect to t. Now we know that X is subject to a uniform distribution of deaths over each year of age. From LifeCon 1, we know that TPx mu x plus t is Qx. Okay, That's because x is UDD over each year of age. So what we can do is we can take out the Qx, and then remember, for constant force, TPx is what? E to the power minus mu t. That's the formula we learned last time. That's why you see for y, because y is subject to a constant force of mortality, we have e to the power minus 0.3 t. And this whole thing they gave us is equals to 0.045. Do the integration, do the integration slowly, clean up the algebra, and you'll get Qx equals to 0.0521. Question number 3. If mortality follows de Moivre's law with omega equals 80, we are asked to calculate this probability, assuming lives are independent. Yeah? We're asked to work out the probability. This is a contingent probability of 70 dying before 60. So if 70 is going to die before 60, so let's kill 70, TP 70, mu 70 plus T. And when 70 dies, 60 is alive, so I have TP 60. That's what you see here. Okay, we are integrating from 0 to infinity and with respect to t. Now, we are looking at TP70 mu 70 plus t. This one here is from our formula those days. We had 1 over omega minus x, remember? So I have 80 minus 70, that's what you see here in the denominator. And then I have a TP60 here. Now we are dealing with de Moivre's law. So TP60 here is 1 minus t over 80 minus 60 is 20. That's what you see here. Okay, 1 over 80 minus 70, I've taken that out, 1 over 10. TP60, we know the formula, 1 minus t over 20. Okay, 20 is from 80 minus 60. This is a simple integral. Deal with it and you will get your answer. Number 4, we have a special fully continuous whole life insurance of 1 on the last survivor. Okay, last survivor of X and Y. You're given that Tx and Ty are independent. You're given mu x plus t and mu y plus t, they are both equal to 0.07. You're given the force of interest. Premiums are payable until the first death. You're asked to calculate the level annual benefit premium for this insurance. A few things. We are going to be using the idea that, remember when we dealt with our last survivor, we used the idea of single plus single minus joint. That's what we're going to use. So we need this joint thingy anyway. So let's work that out first. Mu x plus t colon y plus t. That will be the joint force of mortality, and that will be adding up the individual forces of mortality. Mu x plus t plus mu y plus t. That will be 0.07 plus 0.07, and you will get 0.14. That's what you see here. Then you can work out a bar xy using the idea mu over mu plus delta from our LifeCon 1 days, except that now just be a bit careful, we are dealing with a joint status. So the numerator is 0.14, and here at the bottom we have 0.14 plus 0.05. You will get 14 over 19. Okay, so a bar x will be mu over mu plus delta, 0.07 over 0.07 plus 0.05, and that will be the same for a bar y. Good. So using the idea single plus single minus join, we will have 7 over 12 plus 7 over 12 minus 14 over 19. You will get 49 over 114. And remember, a equals to 1 minus dex. Okay, so we're going to use this formula now to work out our a bar xy, the annuity function. Okay, I repeat, we're going to use that idea to work out our annuity function a bar xy, or you can call it axy bar. So that will be 1 minus a bar xy over delta. Plug in the numbers. 1 minus 14 over 19 divided by delta is 5 over 100. You will get 100 over 19. We're looking for the level annual benefit premium. So we are going to use P equals to A over small a. That's what you see here. Okay. You've got a bar xy bar over a bar xy, the life function over the annuity function. We work this out, 49 over 114, and this one here is 100 over 19. You will get 0.0817. Question number 5, for a temporary life annuity immediate on independent lives age 30 and 40, we're given the interest rate 6%, we're given L30 and L50, and we are given some annuity functions, A30 colon 40 dot dot and A40 colon 50 dot dot. We asked to work out A30 colon 40 angle 10. So let's start slowly. We are looking at an idea. This is your temporary term annuity, 30 colon 40 angle 10. So we know that your whole life, let's write it, last time we learned it in Life Con 1, whole life will be temporary plus deferred. Okay, therefore your temporary will be equals to whole life minus deferred. That's what you see here. So this thing here is A30 colon 40, that's whole life, and this one here is your deferred annuity. Because it's deferred, remember we have something called VN and PX. Just be careful, these we have got a joint life here, so it's VN and PXY. So N here is, of course, it's 10. Okay, it's 10. So this is 10, and then we've got 10P30 colon 40. This thing here will be 10P30 times 10P40. Good. And then of course we have got a A40 colon 50. Okay, so 30 colon 40 angle 10, it will be 30 colon 40, and then I've got VN and PX, and then I've got a A40 colon 50. Now this thing here is an annuity certain, so I'm converting it to an annuity due. So I have a A dot dot 30 colon 40 minus 1, and then this thing here will be A dot dot 40 colon 50 minus 1. 10P30 will be L40 over L30. 10P40 will be L50 over L40. This is of course V10. Use a calculator, you will get 7.1687. Next, question number 6. Z is the present value random variable for a discrete whole life insurance of 1 issued to X and Y, which pays 1 at the first death and 1 at the second death. Again, Z, or some of you may call it Z, is a present value random variable for a discrete whole life insurance of 1 issued to X and Y, which pays 1 at the first death and 1 at the second death. So first death it pays 1, second death it pays 1. Therefore, be a bit careful with the formula that you're going to use. Okay. Remember, Z is a present value random variable, and we asked to find the expected value of Z. They gave me these functions, the annuity function, AX is 9, AY is 13, and they gave me the interest rate. Now, because AX is 9, I know that A dot dot X is 10, and I know AY here is 13, so A dot dot Y must be 14. Just add 1. So AX will be 1 minus DEX. Remember, D equals to IV, which will be I over 1 plus I. That's what you see here. A dot dot X I know is 10. Clean up, you'll get AX as your insurance function as 0.615. Do the same for AY. Okay, the insurance function for Y, 1 minus DEX again. Be careful, this is 14 now. Plug it into a calculator, you'll get 0.461. Remember, this is going to pay 1 at the first death and 1 at the second death. So whether you die first or second, you get paid $1. So we're trying to find this thing here, okay? AXY plus AXY bar, which is this thing here. Remember, we had AXY bar will be AX plus AY minus AXY. So you bring it across to the left hand side, you end up with AX plus AY. We know these numbers, add them up, you get your final answer 1.076923. Question 7. You are pricing a special 3-year annuity due on 2 independent lives, both age 80, and the annuity pays $30,000 if both persons are alive, and $20,000 if only one person is alive. You're given some probabilities, P80, 2P80, and 3P80. Interest rate is 5%. You're asked to calculate the APV of this annuity. Now, I've written the APV in this form. APV is 20,000, A dot dot, 80 colon 80 with a bar, angle 3, plus 10,000, A dot dot, 80 colon 80, angle 3. Now, why is that so? That's because of this, yeah? You get paid 20,000 if only one person is alive, and you add another 10,000 if both persons are alive. That's the idea here. Again, you pay 20,000 if only one person is alive. That's taking care of this. And you pay an extra 10,000 if both are alive. That's what you see here. So I factorize the 10,000 out. I'll have a 2A dot dot A80 colon 80 with a bar angle 3 plus this term here, which is A dot dot 80 colon 80 angle 3. Then what I've done is this thing here, I have used single plus single minus join. Do it yourself, yeah? So you will get A dot dot, 80 angle 3 plus A dot dot 80 angle 3 minus A dot dot 80 colon 80 angle 3. Do it yourself, okay? Remember, this is appearing in brackets, so there's a 2 here. Just be a bit careful, okay? And when you open that up, do it yourself, you will get 4 times A dot dot 80 angle 3 minus 2A dot dot 80 colon 80 angle 3 plus this term here, okay? Once you're done with this part, you are almost done, okay? You simplify that, you will get this, yeah? This is what we are trying to find. This thing here is from our basic annuity days, 80 dot dot, let me say it again, A dot dot 80 angle 3, okay? That is, we're getting this payment here, and this payment here. So I've got 1 plus, VPX plus V squared 2PX. Again, I have 1, did I write it somewhere? I did not. So it'll be 1 plus VPX plus V squared 2PX. That's what you see here, okay? P80 is 0.91 and the interest rate is 0.05, so that's why you see 0.91 over 1.05. You can figure that out yourself. Same thing for this part here, okay? Same thing for this part here. Just remember that TPXY is TPX times TPY, okay? That's why you see the squares coming in here, okay? Good, clean this up, use a calculator, you'll get your final answer. Okay, let's move to the next one, number 8. We have got a continuous 2 life annuity, 100 while both 30 and 40 are alive, 70 while 30 is alive, 40 is dead, and 50 while 40 is alive but 30 is dead. The APV of this annuity is 1180. Continuous single life annuities paying 100 per year are available for 30 and 40 with APVs of 1200 and 1000 respectively. Be careful. Continuous single life annuities paying 100 per year for 30 and 40 with APVs 1200 and 1000 respectively. Yeah? we're asked to find the actual present value of a 2-life continuous annuity that pays 100 while at least one of them is alive. Calculate the actual present value of a 2-life continuous annuity that pays 100 while at least one of them is alive. So, let's start slowly. We are trying to find this. That's what you need to keep in mind. This is what we are trying to find. Now, this number is given to us 1180 for what? For this thing here. So what is this? 100 while both 30 and 40 are alive. Good. That's what you see here. 70, 30 is alive, 40 is dead. That's what you see here. It's a reversionary annuity. That's why you find A bar 30 minus A bar 30 colon 40. This is a reversionary annuity. Yeah? You know the formulas already. And the same thing for 40 is alive and 30 is dead. You pay 50. Another reversionary annuity. Now you open this up. Okay, there's a 30 colon 40 here, 30 colon 40 here, 30 colon 40 here. 100 minus 70 is 30, minus 50 is minus 20. That's what you see here. And then I have a 70 times A bar 30 and 50 times A bar 40. They gave me this. A bar 30 is 12, A bar 40 is 10. They gave me this here and here. So I can write, okay, I can plug in the numbers and clean this up and get my value for A bar 30 colon 40 as equals to 8. Use a calculator. This is what I want to find. Single plus single minus join. I know all the numbers now. Use a calculator and I am done. Next question. You are given 2 lives, age 70 and 75, independent lives. Mortality is as per De Moivre's law. Omega is 100. They gave me A bar 75, 8.655, and they asked me to find this life assurance function, which is based on contingent probabilities. Now, this function here, this life insurance function, I can define it by using integrals because I need to kill 70, which will be TP70 mu 70 plus T. That's the first thing. And 75 is alive, so that's good. And then because it's an insurance function, I have to have my discount function. So that's what you see here, okay? TP70 mu 70 plus T, TP75, and a V raised to the T. And then I have my dt here because I'm integrating with respect to t. Okay, I'm integrating with respect to t. Limits going from 0 to good. Why 75? Because this guy here, the older guy is 75. Okay, the older guy is 75. And we have got omega is 100. So max we can go is 25. TP70 mu 70 plus t. We know from De Moivre's law is 1 over omega minus x. It'll be 1 over 30. And then I can write my function, take out my 1 over 30. Okay, I'll get 1 over 30, 0 to 25, Vt, Tp, 75, dt. Okay, taken out by 1 over 30. Then I have V raised to T. TP75 dt. Now this thing here, we know the value to it because they gave me A bar 75. They gave me this value is 8.655. Take this number and divide it by 30, you will get 0.2885. Good. Number 10, we have a common shock model. The mortality of X and Y follows a common shock model with components. I'm just going to call this Tx star. So it's Tx star, Ty star, and Z. They are independent and have exponential distribution with respective forces mu1, mu2, and lambda. Lambda they gave me 0.01. The probability that X survives 1 year is 0.96. So that includes lambda and mu1. The probability that Y survives 1 year is 0.97, so that will include lambda and mu2. So what's our question? Calculate the probability that both X and Y survive 5 years. Okay, so let's look at this line that I've written. Probability that X survives a year. What's the formula? TPX equals e to the power minus mu t. This is the basic formula, right? We have e to the power mu t. Careful. Now X surviving a year, we need to use mu1 and lambda. That's what you see here. Okay. Mu1 plus, I should write this as lambda. Okay. Lambda is how much? 0.01. So you can clean this up. E to the power minus mu1 plus 0.01 equals 0.96. Take logs, you will get this. Use a calculator, you'll get mu1. Do the same for mu2. Okay, do the same for mu2, you will get this number here. This is what we want to find, the probability that both of them, X and Y, survive 5 years. So my force of mortality now will be mu1 plus mu2 plus lambda. Okay, my force of mortality will be mu1, again, my force of mortality will be mu1 plus mu2 plus lambda, and you'll get the value here. So the rest is easy because we are using e to the power minus mu t. Plug that in, what you just found, t is 5, use a calculator and you will get 0.73609.